Okay, hi, how are you? Today I'm gonna try to solve the following problem. Given a data set of reviews, we're gonna train a model to predict whether a review is either positive or negative. We're gonna train everything local, and then we will upload the trade model to Vertex, and we're gonna try to do inference there. So this is mostly a video about how we can upload a custom model to Vertex and use it for inference. All right. So the first step here is to get the data. I'm gonna very quickly copy the dataset here. This is in workspace, logs intro, and this dataset is called reviews. Okay, so that's done. So we have this dataset here. Let me show it here quickly. And then let me open one of these files. With polarity, text, sentence, negative. And then we have a long list here. I'm just gonna pick one at random. So this one. Okay, so here we can see the review. It's basically just a description of what it was. In this case, it starts with something is fishy in the state of universal. So we can guess that this is not a very positive review in general. And indeed, it was inside the negative category, so you can understand that this is not an ideal review. All right, so what we're gonna do is we're gonna create an environment here to start working. People use poetry and other libraries. I just very used to do it this way. And we will need, at least for now, Python, pandas, scikit-learn, NumPy, and we should be good enough for now. So I'm gonna complete this here. I'm just gonna wait for a second until we get these things installed. And I should be able to start working on this problem soon enough. Okay, these are some big libraries, so it makes sense that it takes a little bit. Actually, we might want to start installing some other libraries that we will need. So quickly here, I'm gonna say pip install transformers and Deutsch. Okay, so now we can leave that running in the background. I'm gonna start my IPython here and we are ready to code. So I'm gonna just name this file main and open it here. It's gonna complain that I forgot to install my language server. We can do that later. And so the first thing we need to do is we need to actually load this data set. So for this, what we're gonna do is something very simple. Load the data. We're gonna do these are gonna be our rows, and then for each of the targets in positive and negative, what we want to do is iterate on these paths. and it's ready. So I'm going to do this paths. It's Let me just import this. There we go. Done. And so now this lives in view polarity, text sentence. This is target. That's exactly what we want. We just missing this. So those are our paths, and then this is basically what we want. Perfect. We might actually want a dictionary here, so let me just transform this into a dictionary. And I need to fix the other one. Okay, now what we need to do is we need to transform this into a data frame. We need to put this, and let's see if that works. So if you're curious, we're just executing things here on the side. So you should see the coder running. Sometimes it takes a little bit. Let me just install. I know why this hangs lately a little bit. Usually when we start, let me just quickly kill it and let's go again. Let's get rows. Let's get the loop done. I think I might have been overambitious by installing all the libraries where we were running the thing. So let's go again. Imports. Let's load the rows. We can look at the rows here. Looks about okay. We can even get the keys to check if it's a dictionary. Okay. All right. This looks a little bit better. And now what we're going to do is I actually would rather have a Boolean target. So we're just going to get this. And there we are. Okay, so we have our data set now. This is already prepped. And now we want to train a machine learning model for this. And what we're going to do is we're going to use BERT embeddings to transform all this text into an embedding vector. And then we're going to use a very simple model, in this case, NS support vector classifier, to classify this into either true or negative reviews. So what we need to do next is we need to get those vector embeddings going. The way we're going to do that is we need to import some libraries. So let's go here from transformers. We're going to import the BERT organizer, and we're going to import the BERT model. And then we're probably going to import Torch as well. That might take a little bit to load. Let's look at that there. It's taking a second. We can keep on writing a little bit more of our code what that loads the import. What we need to do now is apply a bird embedding to a string, and let's see if this makes sense. That looks like some of those things might be useful, some of those not. So that's cool. We probably want to call this outside the function. Okay, so touch loaded, let's call transformers. So we want this. Let's get okay. We also want to define the device. I'm running this on a MacBook M1, so I want to use MPS, and then I want to send my models to device. Here, we probably just want inputs. My embeddings are going to be the last hidden state, and then I need to return my embeddings. Okay, so let's see if this works. This is loading embedding model. That went fast, so we can call this function here. And then let's try to apply bird embedding. Hi, how are you today? Oh, there we go. Let's see what I'm missing here. Doo-doo-doo-dum. String. Okay, yeah. This is not what we want. That's what we want. Okay, so basically what we did here is we we got our text, we ran it through the word model, we took the last layer, and we got this embedding, which is 768 dimensional vector. What we need to do now is we need to apply this to our whole data set so that we get our features for our model. So let's do that. Um, I'm going to import a library called TQDM, which is basically allows us to get nicer outputs and see progress. So we're going to calculate embeddings here. Bird embeddings. Panda apply functions are usually slow, so sometimes I'd rather do this. So this is going to be text, port text in TQDM, df content, and this would work. Let's check it out. Okay, and this is going to take a little bit. So here we are calculating all the embeddings. This is, of course, going to take some time. The next thing we need to do is, because we're going to be training a machine learning model, we might want to split our data set into train and test, just to be able to get some evaluation metrics. So that's what we're going to be doing right now. I'm just going to write a little bit of this code to make sure that it is ready when this finishes. And as you can see, this is a bit slow, especially because I'm running on a Mac M1, and this is basically not the fastest machine. I don't have access to GPU here, so such is life. All right, so while we wait, we can do the following. We can start adding a little bit more code here. We want exactly. We need to be turning these embeddings into a data frame to join it with the rest of our code. So this is going to look something as follows. So the embeddings. This doesn't work as well. We will need to stack this. And this is going to be our X in our problem, in a way. So here what we can do is do the following. We can say, and usually you need to split your data set between train and test, but because we're just applying embeddings and this is sort of agnostic on the split of my data, this is fine. Usually you rather do this at first to make sure there's no data leakage. And let's look at this. This is exactly what we need. So let's just copy that there and wait for completion. Probably something's going to go wrong. It always does. We can continue adding a little bit more data here. So let's train a logistic regression model. Actually, we want a classifier model, so let's do this by hand. And I'm here and say from scikit-learn, we want an SVM. And so here we're going to say, oh, classifier is this. Let's get and we're going to fit it. This is training. And then the other thing we need to do is we need to evaluate. So for evaluation, what I rather do is as following. Let's get the predictions, and then let's get the classification report, and then let's print the classification report. Okay, so we're just gonna move this all the way up. We're probably also missing NumPy. Let's just import it as well. And we're pretty much done. We're still waiting for embeddings to finish. This is going to take a little bit. So in the meantime, we we can wait a second. Once that finishes, we can actually run everything and continue. Okay, hi. So since we stopped recording while we were generating the embeddings, we actually got some technical difficulties and I lost pretty much all of that recording afterwards. So I'm just gonna show you what we built in the meantime, and we're gonna continue from there. So if we take a look here at our current folder, this is what we have. Let's just quickly look at this. So we have our main script. This is where we were before. Here you can see the embeddings. This is the line that we were running. This is basically the line we ran afterwards. We created a data frame with those embeddings. We split this into train and test. We prepare this classifier. It's very simple. We trained it in this line. We generated predictions. We generated the result of those predictions using this line. And then we save those models. So this was fairly straightforward after we got the embeddings. The next step that we actually performed was using the generating a way to use these models and generate predictions. So the way we did that is we actually wrote this script here. We can run some of these things live now. So we can import this. We have this class here that basically loads our model from the three bumps we generated previously, and then uses that to generate a prediction. So we have this class here, predictor, and we can call it like this, predictor.predict, and actually it accepts a JSON with this shape. This is the worst movie I ever saw. So we close this, and we get the response. So that's what the class does. It's basically loading the models and exposing an API to generate predictions. The other thing we did here is that we have, so basically, Vertex, we're going to wrap this in a Docker container, and Vertex expects an, an API through which call and generate predictions. So we actually need to wrap this model, this class, using a server, and we're going to use Flask for that. So here we're creating two routes. One is called predict, and the other one, it's basically sort of an empty route. The empty route is needed because it's used by the model to check the health of our Docker container. And then when it comes to the predict route, we can look at here. We accept a JSON. This JSON needs to have this field called instances. Instances is a list of the predictions we're going to be getting. And then because that's a list, we therefore need to assume that we're going to iterate over the list and generate one prediction for one of those, each of those instances. And then we return the predictions using a JSON with the key predictions. That's part of the contract that we need to certify to get Vertex up and running. And then we can get, we can basically use these to generate predictions. I'm going to show you here. I'm going to run this, which is basically stored in the Flask server. And I here have this bash script, which basically it generates a post to this URL. In this case, is the port 8080 in Flask, and we're sending three requests. This was a great movie. This is a terrible movie. I love this movie so much that it made me cry. And all these are sort of part of the same prediction. And we can execute this script. And we get the predictions here, true, false, false. We can actually just pass that. Okay, cool. So we basically train a model, exported the train model, and run that, wrap that around the class, and put that into an inference server. So this is sort of very generic, and we would have done something very similar where we to deploy this model using anything but Vertex. But because we actually want to use Vertex, the next thing to do is we want to wrap this around a Docker container. So what we need to do is I'm using a base image provided by Google Cloud here. I don't think this is necessary, but it probably removes a bit of the headache. I'm going to try some experiments with other images later. We install all the libraries here. We could write our requirements.txt because this is fairly simple. We're just going to do it here. Then we copy the tokenizer, the model, and our train model, custom model, into the app work directory. We copy the predict script that is used to generate predictions. Look here that we don't need the main script because everything that we actually need to run is contained within the predict script and these models. And then we expose the port that we want, and we say that this Docker is going to execute um, this Python file. So we can actually, instead of doing this, we could do something like this. We could build this. We could build this Docker file. I already built this, so this is going to work out of the box. It will be fairly straightforward. I might not be running Docker. I don't think I was running Docker, so let me just start Docker. Okay, this is not responding. I'm just gonna kill this pane and create a new one. Let's see if this is alive. Okay, there it goes. So I have here a script. So this is how we're gonna be using later. I'm just gonna copy the first command. This should build the file, but it's probably not gonna do much of anything. While it builds. Okay, Docker doesn't seem to be responding. Just restored it. Again, this is what people often call demo effect. All right, so let's assume that this thing actually built. So the next step, basically at this point, we have a Docker container that's built with our image. And what we want to do is we want to upload it to the artifact registry in Vertex because that's how we are actually going to deploy our model. So to do that, what we're going to do is we're going to come here to Vertex. We're going to go to the artifact registry. And you're going to see here that I already created this review classifier here and that it already has an image. That's because basically I uploaded it while I was recording and then that recording got lost. This is the Docker container that we uploaded. It was 3 hours ago. And basically to do that, what we did is we ran this Docker file that pushes the image, basically tags our local image with this string, which is our project. And then it uses the push command to push that image. And the tag should be almost instantaneous. The push command actually might take a while because it needs to upload a fairly large Docker file. I think it was about 10 gigabytes. So if your internet connection is not very stable or you have limited bandwidth, you might want to beware of this step. But once that's done, we we are actually ready to continue just using Google Cloud's UI because we have our model here. And so the next thing we can do is we can create a new model. So we can go to the model registry. And now we want to import a model. We want to import as a new model. We're going to call this review classifier. We want to use this region. We want to leave that as is. We want to import a custom container here. And this is gonna prompt us to select which Docker image we want to be using. We already uploaded the review classifier, so we're just gonna go ahead and select this. We already specified the entry point in the Docker command, but otherwise this is a place where we would do it. We won't be using any of these. We do want here the prediction route. We want the predict, and for the health route, we want this empty route. We are gonna be using port 8080. And that's it. We're just going to disable explainability for now, and then we click import. And so At this stage, we pretty much did everything that we wanted to do in our local machine. We're just working on GCP now. What's happening is that GCP is taking our Docker image and is building the review classifier. This can take a little bit. And once that's done, what we want to do is we're going to have that model and we want to deploy it. And so let's wait a few minutes while this joins the model, and then we're going to see how we can deploy it. All right, so our model just finished uploading and we have it here. It says review classifier, default version 1, and there's nothing on deployment status. So that's something we want to fix. We actually want to deploy it. So what we're gonna do is we're gonna come here to deploy and test, and we're gonna click deploy to an endpoint. And here we get the chance to create a new endpoint. So we're gonna create a new endpoint, and this is gonna be called review classifier. We just want to use one model, so we don't care about the traffic splitting. We here need to configure the resources. We're just gonna go with the smallest machine. We want to enable login and no explainability again. And that's it. We click deploy. Now, deployment is very slow. So this process is actually gonna take a while, maybe 30 minutes. Good thing is you actually get an email or a notification once it's done. So again, we're gonna cut here and we're gonna come back once this model is properly deployed. All right, so the model just finished. It took a little bit. It was almost 50 minutes to deploy the endpoint, and here we have it. So we can actually try this thing here. So we can come back here. We can cut our send request file, and we have here some JSON. So we can copy this. Okay, so we need to format this as a JSON here. This is going to be instances. This is not particularly pretty, but it should work. And so we are going to generate a prediction, and indeed we get the predictions we wanted. This is amazing. So how do we use this model? Well, we can, for example, get here sample request, and it specifies what we need to use this API. So let's make these changes in our file. So let's copy the authorization header. What we're gonna do is we're gonna copy this send request and call it request Google GCP, and let's start editing this. So we're gonna first add this authorization header, and this is the same, and then we need to change this address, so we can copy this. We need to change the project ID. So the project ID is here. And then we need to change the endpoint ID. So endpoint ID is here. So now there's literally no trace of us using localhost. This is just a normal curl calling GCP. And let's try this out. Awesome. So we just got the same result as from the UI. We actually trained a custom model using embeddings from BERT and then using scikit-learn. We package that in a Docker container. We upload that container to the artifact repository. Then we deployed a model. We created a model in the model registry from that container. And then we created an endpoint and that now that endpoint is live and we can use it to generate predictions. That's enough for today. Thank you for joining. Sorry for the technical difficulties, and I'm sure they're going to be fixed for next time.